everyone, I'm just going to do a quick video about what we did in Math 115 on Monday. And sorry, I'm going to be a little late getting this up. It'll be late Tuesday before it's up, but at least you'll be able to see it there if you did miss Monday or if you want to just kind of refresh your memory. So last week we talked about length, area, and volume of all different polygons. This week we're going to be talking about circles and spheres. Okay, so we're going to start out by saying if we have a point P, call it, and we want to find all of the points that are 1 inch away from this point P. So, and we did in class, I said if you have a ruler, you could do an inch or whatever, 2 inches, whatever you want to do, or you could just use something like we said, okay, what if this were our measurement, right? And we wanted to find all the points that are this particular length away from P. So let's say I'm going to do 3 inches, just so it's a little bigger on here. If I want to find all the points that are 3 inches away from P, there's one point that's 3 inches away. And if I go this way, there's another point that's 3 inches away from P. So we talked about where else we could find points that are 3 inches away from P. So in our Zoom class, someone said we could go to the right and we could go to the left. And then we said, okay, well, are there more points that are 3 inches away from P? And someone said, well, you could go in a diagonal. So we could go over here. We could also go down here. And we could do the same thing going this way and this way, right? And you can see that I have an infinite number of points that I can find that are 3 inches away. I could put a point right here, and then I could move my ruler a little bit and put a point right here. And hopefully you're seeing now that if I put all these points together, they're an infinite number, that is going to make a circle. Okay. So think about if you, in your backyard, have a stake, and you have your dog's leash attached to this stake. Where can the dog go? Well, the dog can go anywhere in here, but if they have their leash all the way out and they were to walk around, it would make a circle. Okay, so this is the definition of a circle. So let's write that down first. So a circle is a collection of points in a plane. So a plane means it's two-dimensional. This is a plane, right? It goes left and right and up and down. It doesn't come out at all. It's not three-dimensional. Or your piece of paper on your desk is two-dimensional. Or your grass where the stake is, your lawn is going to be two-dimensional. So it's a collection of all the points in a plane, all the points, in a plane that are a certain fixed distance away from a certain fixed point in the plane. Okay, so I'll give you a minute to finish copying that down. The circle is a collection of all the points in a plane that are a certain fixed distance away from a certain fixed point in the plane. And of course, the nice thing about this is if you need more time to copy it down, you can always just pause the video for a minute and finish writing. Okay, so if we think about a circle, like our circle here, this fixed point in the plane, right, that is the center of the circle. So that's my fixed point, circle. That's where the dog's stake is. That's where my point is that I'm measuring from. So this is the center, okay? The circle is the collection of all the points that are a certain distance away from that point, a certain fixed distance away. So what did we say? Remember we said from this point, it was always 3 inches in this case, okay? So that distance, that fixed distance, it was always the same, went from the center to the edge. And if you remember, if we have a circle, here's my center, the distance from the center to the edge is called the radius. Okay, so that's what this is. The certain fixed distance is called the radius. And then if we go all the way through the middle, so half of this would be the radius, right? The radius is the same anywhere. If we go all the way through, that is called the diameter. There's a little bit of a glare there, sorry. But it's diameter, D-I-A-M-E-T-E-R. That's double the radius. And then the length all the way around the circle is called the circumference. So the circumference is essentially the perimeter of the circle. Okay, we just don't really call it perimeter because it's not straight lines. So if we think about, if I make a circle here, okay, so it's a little bit lopsided, but pretend this is a nice little, circle. Then my circumference, if you can imagine like cutting that circle, it would open up to be one long straight line, right? But then it's been curved to make that circumference. And we'll be talking a little bit more about an activity I'd like you to do with circumference a little later. And that also reminds me that there's some books that I would have brought to your class and shared with you this semester, but I wanted to show them to you too. There's a whole series, and the series features a knight named Sir Cumference, little play on words, and his wife is Lady diameter, and his son is Radius. And there's a whole series of these books, good for middle to upper elementary school, even junior high, and they all deal with math things. So like they're all kind of written like fairy tales almost, stories, and like this one deals with the graphing. You can kind of see it's a treasure map, but it would go along with the graphing. This one, All the King's Tens, talking about place value. There's some about shapes. There are some about fractions, all different things. There's one about pi. We'll talk about that one a little more in a day or two. So those are just really good. I don't know if it's easy to see on one of these. The author of them is Cindy Neuschwander, but they're really great. So if some point when you have your classroom, those are something to maybe think about and remember. Okay, so we have our circle here. So let's think about this for a minute with this circle. And let's say that we have a treasure map, okay? And we're told on this treasure map that the treasure is 30 feet from point A, and it is 50 feet from point B. And from A to B, they are 60 feet apart. Okay. So here's my point A, and here's my point B. Okay, so I know from my treasure map that my treasure is 30 feet away from A. It's 50 feet away from B. And these two right now are 60 feet apart. So my question is, can we figure out exactly where the treasure is? So we did this in the Zoom class, and we were talking about the fact that, if we're looking at A and B, 30 feet from A, if this is 60 feet, 30 feet from A is about here. And 50 feet from B would be about over here, roughly, right? If this is 60 feet, this is about 50. So that kind of doesn't make sense. Like, they can't be, how are they going to be in the same spot? But then we talked about the fact that this is not the only place that is 30 feet from A. If this is the distance of 30 feet, then thinking about what we just did with that other point P, we could also go 30 feet here, or 30 feet here, or 30 feet here, right? And if you think about what we just did, going 30 feet in every direction will give us a circle, okay? Now this isn't as nicely drawn because I didn't have a measurement there, but that'll be our 30 feet circle. So it's 30 feet as a radius. Any of those points on this circle would be 30 feet away from A. It never said it has to be between A and B. So now think about doing the same thing for B. So now this is my my length, right? From here to this X is, we said, about 50 feet, let's say. So if I do that, I can have another one over here. I could have another one up here. I could have another one down here. And again, all of these points, if I measured out what that 50 feet is, it would make a circle around B. Now, it makes sense that the B circle is bigger than the A circle because its radius is larger. It has a radius of 50 feet. Okay. So, do we know exactly where the treasure is? Can we figure out a point where the treasure is that is exactly 30 feet from A and exactly 30 feet from B? Well, we talked it over a little bit during the Zoom session, and we decided that any point on this circle is 30 feet from A, right? Any point on this circle is 50 feet from B. So we need to find a point that makes both of those true. So hopefully you're kind of seeing by now there are 2 points that make both of those true. One is right here, and one is right here, right? Those intersections are where those are true. So in this case, we know we can't tell exactly where the treasure is, but we know it has to be one of these 2 places, okay? Depending on how the size of the circles is related and how close they are to each other, circles can either not intersect at all, okay? Let's say they are too far away, or they could intersect in 2 places like ours, or they could intersect in exactly one place. If it said the treasure's 30 feet from A and 30 feet from B, this circle would have come down here also, and it would have intersected in exactly one spot. This, we're going to talk a little bit more about this later this week, but this is kind of a simplified idea of how things like GPS work, okay? Because with GPS, we're going to talk about it's a sphere, not a flat circle, but basically, if you had 2 satellites and they knew how far away you were, it would be something similar to this. And then if we added a 3rd satellite, and the 3rd satellite said, oh, it must be, this far from this center, now we'd know it's this point and not that point. Or sometimes you can kind of tell anyway, because that second point, one point might be on Earth and the other point might be farther out in space, right? So you kind of know that must be. But that idea, it's called triangulation. And that's kind of the idea of how things can be located. So we'll be talking about that a little more also. Okay, so then, let me just see what else we were doing from here. All right, so then we did one more problem. I'm actually going to stop this video because I'm almost out of time to be able to upload it. So I'm going to stop this one and come right back, and we're going to do one more problem that we did in class, and then I'm going to explain what I would like you to do if you get a chance before Wednesday, or if you can't, then just to do it on your own at some point, okay? So I will be right back with the second part.